this for a conference, and you're talking before 9 a.m. in the morning, there's going to be nothing but crickets. Everyone's going to be hungover, stoned, or broke, right? So I'm going to do a John Masters, if you don't mind, and take a quick little video just to prove them wrong. So if you would all just give me a sign of life, just to prove you're not actually incapacitated due to Vegas's lifestyle. Awesome, thank you. So, as Joe mentioned, I'm going to give a quick surf over the subject of Zephyr and try and tie this into a few views I want to share on IoT security. But first I want to thank Dave, Ebba, George, and all the others from Linaro for putting this together, in particular for the invitation to come and talk. This is my first Connect, and I certainly hope it's not the last. So just a little context of where I'm coming from. Objectivity is an illusion, as you know, so this gives you a sense of my bias. I work in the Microcontrollers group at NXP, and I head up security in the R&D group. I would kick this off by mentioning that this is not a software-specific thing, so I generally come at this area from a hardware point of view. But I have a background in software. For the sins of my youth, I'm a member of a project called OpenSSL, some of you may have heard of. And I've worked around web servers and other sort of network-related activities in open source. And in the hardware side, I've been working on networking, hardware architecture, and over the last couple of years in the microcontroller group, working on apps, processors, and microcontrollers, and all the security subjects therein. Excuse me. I just mentioned at the end, excuse me, for my accent, I'm from Wellington, New Zealand, and I have, I think, the distinct privilege of being one of the few Wellingtonians that was not involved in any way at all in Lord of the Rings. So I just mentioned that. An ungenerous colleague actually described me as looking like a retarded elf on a bad hair day, so. Excuse me. So the agenda I came here with, what I was hoping to cover was to give you a broad sweep of the Zephyr project, talk about, you know, the where, the why, the how, the when, and all of that. And then to go through IoT security, which is really more my topic and it's my interest. However, there's been a lot of talk already about Zephyr. And for those of you who are fortunate to be here Wednesday afternoon and see Anis's talk on Zephyr, he's already done a lot of detail on this, and that's videoed, it's online. So for detail, I strongly recommend just going and taking a look over that at your leisure. I won't try and regurgitate, and in any case, couldn't do justice to that. So I'm going to keep it relatively superficial in terms of the Zephyr project per se, and to try and home in on some of the security considerations more specifically. This is I guess a marketing slide, so we'll try not to, thank you, try not to dwell, but the code base behind Zephyr has been around in various different forms for about 20 years. It's been in aerospace and a bunch of other industries, so this new project is not necessarily new code, and but it's been given a new lease of life. It comes out of Wind River. It's a cross-architecture RTOS, and I think Intel somewhat courageously had sort of realized that when you look at the dynamics of Linux and you look at successful open source projects that attempt to provide a kind of positively commoditized code base, that the best avenue was in some sense all of us ceding a certain amount of strategic control so that the dynamics of the open source development model would kick in. And given where we are with IoT and how disruptive it is right now, how much creativity and how much churn is going on, we're quite hopeful that that development model put in place now with that code base and with a critical mass of parties engaged means that there is a good chance that we will see this take off. These are the platinum members that are on right now. So NXP, Linaro has just joined, and we're super happy about the Light group. We really have high hopes for that, and dare I say, high expectations, Matt. So NXP was involved from the outset. I was really enthusiastic about this. I've kind of been championing it to anyone who'll listen, and so I'm on the governance board, not on the technical side. So again, I would defer to Matt, Kumar, Anas, they're all here. If you guys want to find out more about Zephyr, find out some deep technical details and get involved at a coding level, you got the right people here. And we have Intel, of course, and Synopsys is also there, and we're expecting this list to grow over the next few months. And quick view of the project model, the governance model. So this is an attempt, if you will, to consolidate both the open source meritocratic development model. We have a technical steering committee and I think a pretty good community model for everyone being able to just lean in and do what it is they want to do without any of these, key commercial entities really getting in the way or constraining the development and the innovation by petty strategic concerns. But at the same time, to provide it with a robust critical mass of backing. We have people funding this, we have budgets, we have marketing. I'll get into the security side shortly. We have a charter here. This follows the Linux Foundation model. They put this thing together and brought the members together. And so we have a charter. The governance model is involved in things like that. If we need to change things in the charter, if we need to do things about what we're budgeting, what we're actually funding in terms of just accepting, then that becomes a governance question, marketing and security. But the key technical activity is intentionally decoupled. So we're trying to have the best of both worlds in that respect. I guess this is what we've been harping on since Monday, is we would really, really welcome people getting involved, participating in whatever way suits you. We're still at a very formative time with the project. There's a lot of flux, things are moving, lots of really interesting discussions going on as to security. Again, I'll come to that in a second. The networking stuff right now is undergoing a lot of examination and we're making a lot of key decisions. So people who get involved right now are going to have an opportunity to participate in that and have an influence on where this goes. I guess the key point here is that for people who have things that they want to get done, we're trying to make this in some kind of metaphoric sense. And of course, you can stretch the metaphor, but we're looking to have a kind of a Linux for MCUs, where if you got an itch, you scratch it. The barrier to entry, the tools are free, they're easy. The code, it's Git controlled, the layout's pretty straightforward. People can just get in there and start rummaging around and seeing what they can come up with. So I should also mention, of course, it had occurred to me yesterday when I was reviewing my slides that there is a somewhat unfortunate reputation in the open source community that developers are shabby and hairy and of questionable personal hygiene. That was certainly not the intention of that image. So what is IoT security? There is an awful lot being said on this topic. I'm not going to try and evangelize an NXP-centric view or product-centric view or a business and marketing-centric view, but that does tend to be the dominating formulation for what we mean by IoT security. So I'm going to try and dig into the terms a little bit and bring it into sort of an engineering perspective and try and give meaning to what I'm subsequently going to say. But I wanted to share with you, we have a marketing group has cooked up a neat little presentation, and this is...
Security is a big challenge for the Internet of Things. You can't avoid it. We're talking about people's homes, security cameras, and health information, and infrastructure like roads and buildings. If people don't trust that they're secure, they won't deploy IoT devices. And that's why the Zephyr project is an RTOS designed with security in mind for small footprint IoT devices. Mere cryptography isn't enough anymore. So that's why Zephyr goes further. At its very foundation, Zephyr runs on single executable binaries, meaning every feature is compiled up front. Throughout the project's development, every component goes through a rigorous lifecycle to check the security of the feature. Once a feature is added to the project, it's reviewed for security and compiled into the static binary. This doesn't stop bad code from existing. It's a fact of life in software development. So the Zephyr project is designed around tools and processes to minimize the risk of insecure code being included. A community of project members reviews every feature to make sure that sound security practices are applied as code is implemented into the Zephyr project. And features that relate to security get extra scrutiny through our security risk assessment. Regular code reviews ensure compliance, functionality, readability, and maintainability. Static code analysis finds complex and significant functional and security defects. And survivability ensures that security vulnerabilities that happen upstream from Zephyr are addressed and disclosed appropriately. The result? When you incorporate Zephyr security updates, your edge devices become more functional and more securable. And we're just getting started. We have several groundbreaking features in mind, and we're looking for thought leaders to help build them out and add more. IoT is the future, and Zephyr is the future of IoT. You can help make the future of IoT more secure by downloading the code and contributing. Join us by visiting zephyrproject.org today.
So, when I don't have a cold, I really do sound as slick as that guy. But this is obviously a view of Zephyr that we're trying to, that we've put together in the hopes of addressing the kind of people that you are not, which is to say marketing people, business people. These are the people that we need to key into it and provide a formulation for what we're doing that they will understand. And so that's why I felt like sharing that with you today. But what I'm going to try and get into is to peel past some of this high-level view and share my personal thoughts on IoT and security and what we think that means. And so to talk about IoT security, I guess we need to talk about IoT, and that I think is the most complicated term right now. There's a lot of nonsense that's been said on this topic. It is usually attempted to be described in terms of markets, segments, form factors, products, basically. And that's an inherently problematic view because, of course, it tends to grow. You can't find an IoT slide deck today that doesn't include automotive, for example. But from an engineering perspective, a lot of those distinctions are kind of artificial. You know, a lot of the software practices, a lot of the security concerns are essentially, you know, the same within what people define as IoT and without it. So from an engineering perspective, and certainly from a security perspective, when we've been looking at this and looking at what we're doing with our development and our research, I think about the best way of defining this we've come up with is simply to say that IoT is whatever was previously offline coming online. And it's a very flippant description, banal perhaps, but I think the consequences are non-trivial. And that's where it starts to get interesting, because this is how we can start to address what the actual security problematic is here. And what is security? This too, I think there's a cliche that an image is worth 1,000 words. I think this one proves that the converse is sometimes true as well. Security is a very vexing term. So I'm just going to start off by looking at a couple of example sentences, and it's sometimes worth asking yourself, do you ever find yourself saying things like this? Do you hear people saying these sorts of things? Adding security to the product, you know, integrating security, for example. You hear that quite often. It begs this question, right? What on earth are you talking about? On a daily basis in my job, I find people saying these sorts of things to each other, and they both have completely independent and unrelated interpretations of what it is they mean. And so it's a problematic word, and it's highly misused. It's largely a psychological and an emotional word. It's supposed to make you feel better. Oh, it's secure. Okay, but what does that mean? And it's an interesting exercise, by the way. If you start going into conferences and talks, I suggest having this little mental exercise in your head and just wait for the word to go flying past and ask yourself, does that guy actually, or that girl, really make clear what they're talking about? I'm going to peel this down a layer or two to try and illustrate where I'm getting at. I hear it used in all of these ways. Some people are referring to devices that are tamper-proof, resistant to side channels, and so on and so on. All of these things. Even the last one, in fact, is one of the key usages, and But all of these are very different from one another. Did you review the code, right? For complicated code bases is in many ways one of the most critical security aspects of your development. And if I dig in even a little bit further, this is still an incomplete list, but I've tried to just motivate what I'm talking about here. Security is a many-faceted subject. There was, in fact, it occurred to me there's another area that we're having discussions with people about right now where you would incorporate for subjects like insurance, risk management. These are also security topics going forward, but I'll come back to that. Emergency planning is another one. So, it still brings us back to our original question. I haven't answered it. Security, essentially, on its own means nothing at all because it's trying to mean too many things. And what it means is usually context dependent, and this is where we're going to come back to IoT. One way of seeing that is thinking of security as the minimization of insecurity, flipping it on its head, or minimizing threat. It helps to stimulate an understanding of how wide a subject it is. And so coming back to IoT security, I think this is one of the key, this came up, I forget who it was who said it yesterday, but somebody had made the same point in the mini-conf in the afternoon. What we see is there's a convergence of two different kinds of security topics. You can slice this in different ways, but I think this turns out to be a key way of looking at it because of the consequences. Device security is a topic that covers, in particular, physical attack, but it addresses the fact that there is an individual entity that is subject to some kind of compromise, whereas network and logical security is really more an attack on the design rather than an attack on the object or attack on the individual entity. As these two collide, we tend to find that fault line is more or less what we're talking about with IoT, and in particular with IoT security. And it gives rise to a couple of very, well, first off, actually, this is just an attempt to take all those items I listed off before and just to try and break them out into these two areas. It should be taken with a grain of salt, of course. There's a lot of things here which ought to find themselves on both sides. I mean, cryptography is implicit in both. Side channel and timing attacks apply to both of these areas as well. But more or less, that's a rough separation of the kinds of security we're talking about in device security and what we're talking about in network and logical security. So, the interesting thing here is when these assumptions collide, what we find in device security, if you actually look at the science around secure elements, you know, banking and passports and you know, critical security, but electrically low complexity devices. There's an awful lot of engineering goes into these things, a huge amount of engineering, and almost as much work on QA, certification, and those sorts of activities. And it's a very static, monolithic way of working. Network security, from the other side, if you work in servers, networking switches, and those sorts of things, for the last 20, 30 years, you've already well adapted to this reality that things are dynamic. Threats are evolving, change has to accompany that. And so these two things do not combine terribly well. And so IoT, living on the forefront of both, is therefore an inherently problematic topic area. Furthermore, I forget the exact statistic, and it may no longer be relevant, but there was a statistic a couple of years ago saying that by 2017, 2018, over 50% of the IoT edge nodes were going to be produced by companies, startups, that were 3 years or less in existence. And so it's certainly indicative of what's going on. We're no longer talking about the kinds of manufacturers and large companies that can bring to bear armies of security engineers and resources. We're talking about often mom and pop shops and small outfits who are spread very thinly. So I've tried to represent this in terms of risk multiplying and defense demultiplying in terms of what this is doing to the attack surface, what this is doing to what we need to address. IoT, of course, is going to suffer from its success in terms of the proliferation. There's a huge amount of deployment. The number of nodes is astronomical and growing astronomically. They are, again, a combination of both attack surfaces. It's a horrible combination in that sense. The attack surface is large, and of course the incentive for attack is large. On the flip side, it's being driven far more heavily than any server ecosystem in terms of commodity pricing. The margins on these things, the resources that can be consecrated to development of IoT devices is very precarious. And so often preventative, proactive security work is the first thing to go in terms of rationalizing where you put your engineering effort. So commodity pricing is going to be a big issue. Finding and fixing bugs is going to be an issue when things are so heavily proliferated, and you've got developers who are doing everything from raising VC funding, producing demos, cleaning the toilets, everything. They just can't bring to bear the kind of security expertise that objectively would be required to do justice to these products. And so reactive security, which is the topic area of security which deals with what do you do once you've shipped. It's all very well to talk about working towards something that's production worthy. Once it's out in the field, how do you then handle things? So reactive security is going to suffer in all likelihood. And of course, the proliferation of these nodes means that we may be proliferating a zombie network from the outset. So that's the apocalypse story. I know everybody has their own IoT security apocalypse story. That's mine. I want to just draw your attention to a couple of observations about the traditional microcontroller engineering world, which is, I think, at least in the context of our IoT discussion, is largely about this sort of thing. Non-networked devices that find themselves in these verticals. Industrial and medical are good examples. Automotive is becoming increasingly a good example as well. And they're heavily engineered for what I call a static state of optimal security. All of the work is done in sort of an NPI mentality up to the point where it's ready. Ship it. We've got certification done, code reviews, analysis, testing. We move on to something else. That, of course, is problematic. Furthermore, what we also see is in the IoT apps processes and increasingly the microcontrollers as well, this trend where their capacities and Moore's law and all the other kinds of trends there mean that the complexity of what we can and do with the software means that we can no longer live in a static world. We have to confront the reality that these networking people have been dealing with for decades, which is that the complexity threshold has been crossed. You can do your best to build a secure software. If you give it to me and you walk away, it's not secure anymore. That's the point there. So reactive security is going to be something we have to bring to bear on the microcontroller world, which is not something that it's geared for, at least to a large extent. It's a very different mentality. It's the device security mentality, and we need to bring the network security mentality to it. So I bring up DLM. If you've been to, say, a big security conference like RSA in the last couple of years, you would know that when RSA is in San Francisco, you can't shake a tree without 2 different DLM solutions falling out of it. Everyone was talking about cloud-based patch management, over-the-air updates, and so forth. Unfortunately, that is, and I don't mean to be too cynical about those are important and essential things, but in a kind of networking metaphor, that's really just the last mile of the solution. And the opportunism around it means, to a large extent, when you're being proposed DLM, you're being proposed to provide a licensing revenue to someone who wants to embed a root of trust and get engaged in how you sign your images. The point I want to make here is that this can lead us to a false sense of security, in that we're talking about how we get the updates down to devices. We're not talking about what is it we're updating and who's working on it, who found out about the problems. Where is the actual code activity around maintaining security upstream and all the way down the supply chain to the point where DLM can even be a value add. So it's part of the answer, but it's far from the answer. So reactive security, as I mentioned, is something that the networking space has been dealing with for a long time. I in particular have a lot of painful experience with this in the OpenSSL project, where we're on a war footing. Problems are being found, they're being disclosed in various different ways, and we have to cope. And we're dealing with a lot of downstream activity that we have, how do you manage this? How do you deal with embargoes? How do you institute the appropriate policies? And so on. But then the question might be, well, then can we just adopt the same methods and bring those over? That would be nice. There are at least a few problems with it, though. The way things are handled in the networking world is around CVEs, the common vulnerability enumeration, and CPEs, which is common platform enumeration, and all of that kind of activity. There's organizations like CERT. In fact, there's a few different CERTs. There's first.org. Those kind of organizations that bring together closed and open source upstreams to deal with the real-time handling of security issues. They have evolved this scheme which is starting to crack a little bit. It was already being pushed. A couple of these key issues are already to be found in those devices and in those kinds of systems, where this kind of vulnerability handling, I don't want to get too much in the detail, but just to try and illustrate, this deals with security on a product basis, which is to say a product typically has an operating system, has applications, has a package management solution, and anything else, any kind of complicating firmware, any subsystem, any kind of intelligence buried down beneath that level is typically handled as a kind of opaque package. It's just a binary firmware package. You've probably seen this in wireless, for example, with Linux distributions, where what may be a fully fledged system in need of its own maintenance is just treated as some kind of opaque binary bundled into a package, and at the product level, that's just seen as an application. They've been surviving with that. We will not. What we find, for example, is that we have products that are based on a microcontroller with a particular kind of software that would be worthy of this kind of vulnerability tracking. And yet, what is one product's operating system turns out to be a subsystem of a subsystem of a subsystem of some other much larger product. And so how do you track vulnerabilities that are applicable to both but entirely different contexts? So the current vulnerability handling scheme doesn't work very well with this. And I'd like to draw your attention to the last point. There's some nastiness buried in this, because what you also see with the traditional operating systems like Linux and servers and networking is that the supply chain typically is adding. It's adding packages, it's adding layers, it's adding configuration, and so forth. What we see in the microcontroller space is that the supply chain tends to be modifying and transforming. So whereas you might be able to talk about a supply chain in the traditional sense, talking about a package or some upstream code that has an issue and needs to be tracked, we need to figure out who's affected and to deal with that. You can track that down the supply chain, typically. It's very difficult, actually, if you look at the way things are done in the microcontroller world, where that supply chain is actually fundamentally transforming, tearing apart, combining, and producing a result which it's really not clear what the relationship between the upstream and the downstream is anymore. So these are all unsolved problems. I raise them because within Zephyr, if we're going to do justice to IoT security going forward, we feel that it's incumbent upon us to look at these and to have Zephyr be an example of whatever it is we think needs to be done. So certification is another subject. I think there are already efforts out there. People are talking about different kinds of regulatory or other standards and metrics for evaluating what security means and when it's good enough. How can you validate that something is worthy of being deployed? The problem here also is that this topic comes from the device security world. It comes from a world which builds it static, deploys it, and it just better work. The update mechanisms were never a possibility in any case. So The certification has sort of followed this. Certification is almost entirely, today, about evaluating IP. You evaluate hardware IP, you evaluate software IP, you do all sorts of things to try and assure yourself that it meets the necessary requirements, and then it's done. The problem with that is that ipso facto prevents you from making modifications. It is allergic to change. And of course, what do we know from the networking world is that if you're going to be secure, you have to actually, on the contrary, change immediately as soon as you find something. So certification has never had much traction in the networking world. You've probably noticed. IoT brings these two together. You've seen the hacks, right? The baby monitors, screaming Metallica songs at poor children, and cars getting run off the road by teenagers and so forth. The need is the push is going to come. It's not going to be acceptable, and so people are going to be asking for standards that can be measured and that can be brought to bear, so that can be got under control. And I think we're going to hit this problem, is that certification is actually going, in its current form, to work against us. So we're exploring a lot of ideas. We, in particular in NXP, about what might be done there. And it seems that at least part of the solution is to actually not certify, or in addition to whatever kind of certification you do of implementation, is to in some sense certify the maturity of how you deal with software, how you get it to a point that it's ready to ship, and then how you deal with that software going forward. Do you have the appropriate policies in place? Do you know the provenance of everything in your system? If the vendors of those components go out of business, do you still have a way of properly decommissioning the device or getting a scroll into their code or their keys? There's kind of a process thing there, which is a kind of de facto part of networking security, but has never really been formalized in this way. So as certification requirements come to IoT, there is going to be this question: is how do you formalize that? And so, where does Zephyr fit into this, or where might Zephyr fit into this? I'm going to present a few sort of personal views, and that's all they are. This discussion is still in its infancy, I dare say, but hopefully it'll motivate some brighter people than me to get involved and to help. One of the things we are doing, this has been baked into our understanding of how the Zephyr project will be handled going forward, is to, well, actually, I'm getting ahead of myself. Let's first just look at an example where you have some kind of upstream code base, and someone, to whatever certification profile might apply, is looking to certify that. So they're pulling down the code, there's a few modifications required, they get certification, of course, further down the path, if you see the x-axis chronologically. And there's a couple of complications with this. First of all, the upstream code generally is not being developed with this in mind. So there is no kind of constraint on what changes have to be made in order to reach that certifiable state. And by the way, I'm waxing a little lyrical here. Certified, auditable, we're talking about hardened code. And then what we pile onto that in terms of certification and auditing and so forth is kind of a secondary thing. We are talking about a security hardened code base, which is a slower development than typical mainline upstream. So there is no constraint in this model to the complexity and the delta required to take an upstream code base and make it certifiable. And of course, this means down the line, the reconciliation of updates and future releases with that certification activity is inherently complicated. So what we've baked in to the Zephyr project is as you recall, we had the governance model, and security subcommittee was one of the subgroups of the governance board. The idea here is that we want to have this hardened activity within the project. And we're trying to have our cake and eat it at the same time. So I'll try to elaborate what I mean by that. By having this hardening exercise within the project, we want to create a kind of coupling between that activity and the mainline upstream, so that there is a feedback loop there that keeps, as much as possible, that distinction constrained. and that this would be a continuous process. So we can say to you, you can go off and make those kinds of changes, and that's fine. But if you start changing this thing here, next time we run certification, we're going to have a world of pain, so we have to manage that. Have those activities intertwined in some way. It also creates an incentive for a better mainline, because you are going out of your way to make sure that the mainline is as close as it can be to a hardened tree. It's in everyone's interest in this model. And of course, to do so without slowing down the rate of development and innovation going on in that mainline. Because as I say, certification and similar activities tend to be very laborious, formal, and it's not amenable to the kind of open source activities that most of us are fond of. So this is where we're trying to go, and this is where we hope it'll happen. We have the technical steering committee, which is where the actual code and expertise is it's where we bring in the community and we engage and we provide an environment for that kind of development. We have the security group, which is, of course, thinking about precisely these issues, and to have them working together. And so if I try and summarize this kind of scatterbrain assortment of security topics I've raised, we want the RTOS to be as production grade as it can be, and consistently as production grade as it can be. We don't believe that there's anything to be gained by a throw it over the wall model. And unfortunately, I think that's quite prevalent in the microcontroller world. The vulnerability enhanced, I've said light type tech. What I mean here is these form factors, these kinds of products that are that have this problem of systems, as it's sometimes called, or subsystems of subsystems, looking at it the other way around. And the security quality activities integrated into the project, and all of this, trying to contribute in some modest way to the emergence of some sort of best practice around IoT security, and to do so where we have a project we can sort of be a living, breathing example that will walk the walk and practice what it preaches. So I appreciate your patience. Thank you for bearing with me. And these are all interesting topics and passionate subjects I'm passionate about. And if any of you would like to come and see me and talk about this, please do. But a lot of the key people in Zephyr are here. Light people are here. Engage with them as well. If you have any thoughts on this, we could really use all the feedback we can get. And of course, if you've got any itches to scratch, don't hold back. Thank you very much.
Okay, thanks, Geoff. I do want to introduce, just for a minute before we go, Matt Locke. If you don't know Matt, Matt's the director of our new Linaro IoT and Embedded group.
Thanks, Geoff. I think that was a fantastic presentation. It really covered a lot of why we're doing light in a couple ways. So I wanted to touch on that a little bit. I got a lot of questions this week after the announcement. What exactly are we doing? It would take another hour to talk about everything we're doing, at least. I don't think we want to sit around for another hour. We got coffee waiting for us out there. So I'll just take a few minutes to highlight a few things that we're trying to solve. I started doing embedded Linux, it was almost 20 years ago. And back then, what people did is they pulled down a kernel, they hacked on it, they shipped a product, and moved on to the next thing. And the next product version, pull down another kernel, repeat that work. Nothing ever went upstream. And it's taken quite a few years for the general industry to get back to that model of upstreaming. Thanks in a lot to Linaro and the work we're doing here. So if we looked at launching Light and what we should do, we looked at IoT, of course, and what are the major device types out there. Microcontrollers dominate IoT on the device side. So it made sense for us to look at the microcontroller. But obviously, Linaro is known for Linux, not necessarily for doing microcontroller stuff. So we looked at what are the OEMs and the semiconductor manufacturers doing for microcontrollers. And it turns out they're doing the exact same thing that was being done on embedded Linux back then. That there's tons of great open source projects that are being leveraged, but people are, and this applies to OEMs, makers, and the semis, that People are taking these open source projects, they're hacking as fast as they can to get a product launched, to get it the features implemented and done so that you can get the product in the market, make your revenue, but they're not yet adopting that full open source model. And for good reason. When you're first starting in a new thing in a new industry, it's all about moving as fast as possible. And when we saw everybody doing the same thing, obviously Linaro's model of collaboration and defragmentation of these spaces makes a lot of sense. So we started looking at what are the open source components being used on these devices, and there's probably 3 or 4 major open source real-time OSs that are out there that have a pretty long history of developers and projects. There's IP stacks, multiple IP stacks, multiple TLS implementations. As you look at what a stack of software is for the IoT space, every single one of those components in that stack picture has 5 or 6 implementations out there. And it's really spreading the resources thin across the entire market. And I think it's even, we'll say it's even slowing down slowing down innovation in the IoT space. You can take with a grain of salt all of the market analysis stuff about how many devices and how much money it's going to make, but every year it's in the future, right? That this space is happening. Well, it's supposed to happen in 2017. It's supposed to happen in 2018, 19. You can see that kind of movement along there. And I think in large part it's due to the fact that people are spending their time on these commodity problems, that they're not spending the time on innovation. They're all doing the same hacking on an IP stack to make sure that it works in the small footprint with all the latest IPv6 features and everything that goes into that. It's very complicated. The other parallel to the embedded Linux world is that back then when people started using Linux in the embedded space, there was kind of 2 things that drove the adoption, just to oversimplify. One is that all these embedded things were now connected to a network of some sort. So it no longer made sense to rely on a proprietary network stack. It made sense to leverage a collaborative development of the IP stack and not have all these people doing proprietary ones. And the other part was security. As security becomes important, that also you can no longer rely on a single vendor to give you the complete closed source implementation and just rely on that one development team to fix all your security problems and identify all the security problems. It makes much, as Geoff pointed out, one of the key things in this space in general for security is code review. So the more open source things we have, the more eyes are on it, the more review we get. So that leads to why we started Light and are focusing on some of the microcontroller projects and in that software space. So I don't know if everybody was able to attend on Monday, but we had an introduction to 3 of these projects, open source executives and the other pieces of the stack in there. So we had an intro to Zephyr, we had an intro to Embed, and then we had an intro to Minute. And all 3 of these have some very interesting and great technologies, and we're going to be working with them in Light in some fashion. Today we have a mini-conf that Joe had mentioned. So today is the Cortex-M software mini-conf, and we've got 3 sessions there. The first one is in device model, system model. So how can we quickly get not only our members, but hardware in general ported to the open source projects that we're working on, in particular Zephyr and the other ones I mentioned. So there's some interesting ideas that we have there. We're leveraging our experience from the Linux and Cortex-A side. We think we can bring some of that knowledge to the Cortex-M side of things and really help standardize the way you port to these SoCs, Cortex-M SoCs. The second one is in build and packaging. So another problem space in this area is that with all these open source projects, they're discrete components. There's not really a distro. There's not really an open embedded type thing where you can have a package management system be able to pull from these different open source projects, get it all built and integrated together like we're used to in the Linux world. Most of the developers in this space are either on Windows or Mac in an IDE, and they're used to having a single stack of software provided from a vendor that they work on. So to move to this model of leveraging open source software in the OEMs and the actual developers, we have a lot of work to do to get us to the point where that stuff can be leveraged like we're so used to on Linux. So that's another big area that Light's going to focus on to really drive this collaboration, defragmentation of the market and allow more developers to do things faster. And then the third session we have on the mini conf is around security. And obviously, you heard with Geoff's presentation that it's absolutely critical that we talk about security from the beginning of what we're doing. It's not going to be something that's left to the last. So hopefully you guys can attend some of those sessions and hear what we're working on and contribute. It's a mini conference style session, so we expect lots of interaction and discussion, and we're pretty excited about that. I think that's, there's one more thing. We have, I think Joe had mentioned this too in his slides, there's the embed guys from ARM have some hardware in our hacking room, in the Light hacking room. I think they're going to set it up this afternoon, and then people are more than welcome to come by and get a little intro to it, play on the boards, do some hacking on it, and then there's a session tonight that they're hosting, I think with pizza and games and stuff, where they're going to kind of focus on answering questions and playing with the hardware. Thank you. Hopefully I didn't miss anything I was supposed to say.
Okay, everyone, grab some coffee outside. Have a great day. We'll see you back here tomorrow at 8:45.